Hi everyone, so I'm going to go ahead and show you how to do the warm-up. There are three main ways you could have done this. I'm going to quickly try to go over all three. You can skip ahead though, like if you feel like you have the answer, skip to the answer if you want to just verify your method, or if you want to see other methods, like if you felt like, man, this was kind of long, I have two shortcuts for you. So let's see what it says. It says your credit card bill is $250 at 15% interest. If you never pay off your bill, how much will your bill be after 4 months? So this is where we left off last class talking about interest rates. On all three of these methods, I do need to switch that 15% into decimal form. So it has to become 0.15 or 0.15, depending on whichever way you like to write it. Both are the same. So what I'm going to go ahead and do is I'm going to take my credit card bill of $250 and I'm multiplying it times that interest rate, so 0.15. So 250 times 0.15 does get me 37.5 or 37.50. So this is like saying your bill was $250 at 15% interest. You're going to pay $37.50 in just interest. I then have to add that to my bill of $250. So this is my interest. This is the bill, or like how much I spent, I should say. So I should say I spent $250, but I'm getting charged interest, so I have to pay $37.50 in interest. I add those together, and altogether my bill will be $287.50 or 0.5. This is after 1 month. If I wanted to keep going, I have to do this for 4 months here. So I would go 287.5 times 0.15, because now when I take, like if I act like I never paid this bill off, when they charge me interest rate, they're going to charge it on this 287 amount, not the original 250. So if I have to get charged interest rate again, it's going to be 287.5 times 0.15, which that's going to go ahead and be 43.125. You could round it to 43.13 or 43.1. That's the interest I'm getting charged. I still have to add in that 287.5, and then I'm going to add these together. And I am just adding them in my calculator. I'm not doing it by hand. 330.625. This would be my bill. So let's see. This was my original bill, 250. 287 was after 1 month. 330 would be after 2 months. And I would have to keep this process going. So for 3 months, 330.6, I'm gonna round this up to 3, times 0.15, and then I would have to add this amount, whatever I got, to the 330 again. So as you can see, it gets pretty long and kind of tedious. As a final answer, after 4 months, you should have something about 437.25. The 0.25 might be slightly off depending on how we all rounded up higher up, but you should end up with this after 4 months. Again, we didn't do 4 months here. I did 1 month, 2 months, and then my answer over here would have been my 3 months if I would have continued off of here. But this is just a really long process, and I want to go ahead and get to the shortcut part. So if you continue doing it this way, totally fine. It will always work. You should have ended up with 437.25, about there. Which is basically saying if you don't pay your bill of $250, after 4 months, you're going to end up with $437 because you're going to get charged a bunch of interest. As a shortcut, what you could have done, so I'm going to do shortcut 1, and then there's another shortcut as well. So it says your credit card bill is $250 at 15% interest, right? Well, you can say, okay, 15% interest, I know that means I have to add like we were doing over here on my left side. So instead of adding every time, I'm going to go ahead and just take that 0.15 and add it to 1. This little +1 section takes care of the interest aspect of it, interest. If I said something like a percent decrease, or like when we were talking about taxes, it would be 1 minus. So if I said it got taxed at 15%, it'd be 1 minus 0.15. But since we're saying interest, we know interest means you have to keep adding it together. So it's 1 plus 1 plus 0.15. So when I add those together, 1 plus 0.15, I do get 1.15. Now what's nice about that 1.15 is I can actually just take my initial value of 250 and multiply it times 1.15. So I'm going to do this in my calculator, 250 times 1.15. 250 times 1.15. It gets me 287.5, which was my answer after 1 month here. You could see how they match up. So then what I'm going to do is I'm just going to take that 287.5. I'm going to multiply that times 1.15. Multiply those together, 1.15. And I get 330.625. I'm going to go ahead and round it to 0.63. I'm going to get rid of this real quick. And then you could see how these answers are matching up. So this was at 0 months, 1 month, there it is. My second month, 330.625, there it is right there. And you could see how much shorter this is. So if you're able to shortcut that and just put that 1.115, you could save yourself a lot of time. So if I multiply these together here, 1.15, 380.22, then I'm going to multiply it times 1.15 again. Oops, there was a 0 there. And then that should get me 1.15, 437.25. And let me count real quick. So this was after 1 month. This was after 2 months, 3 months, and 4 months. So my 4-month payment will be right there, which it matches up with what we said we'd get here. So if you're able to convert this, the 15% interest into 1.15, it basically saves that adding step. So you don't have to go in and add every time, like how we did over here on the left side, how we had to keep adding. If you just multiply times the 1.15, you can just multiply and get your answers there. What's also nice about this is it's going to look a little messy for a second, but what's nice is it does let you create a nice table if you wanted to. Like you could take these values and just put them in a table, and now you have them there where you just multiplied by 0.15 all the way down. So that's an option as well. Let me make this go away. Okay, final shortcut method. Again, you can just skip to wherever you need to go. But the final shortcut method, sorry, I'm running out of a little room, is you can actually just take that 250 and that 1.15, and you can raise it to the power that you need it to be. So since we're talking about 4 months, I'm going to raise it to the 4th power. So this is here, that 250 is your initial value. I can go ahead and write that. Initial value. That was your starting point. You started with 250. That 1.15 is 1 plus that percentage, which is what we did there. And then the 4 was the months. So I could say 4 is the months. If we were talking about years, it would be years. Remember, it stands for our X, basically. And our X is usually a time. Okay, that was just labeling everything. I'm going to go ahead and just rewrite it, get all this mess out of the way. And we're going to go ahead and just do 1.15 to the 4th power. So we're working in PEMDAS, parentheses, and then you do your exponent. So I'm going to do 1.15 to the 4th power in my calculator really quick. So you should get change the color, 1.749 about. You might have rounded that. Then I'm just going to multiply that times that 250. So I'm going to do 250 times 1.749, and I get 437.25, which was the bill after 4 months every time. So these are 3 different ways to do the same problem. You take the 15% and keep adding it in like we did on my left side over here. And then by the end, again, it's a long process, but you'll get the correct answer. So even though it's long, you will always get your right answer this way. On the middle column, you could just multiply times 1.15. And then that'll be the pattern you keep multiplying down. To shortcut that even more, you do 1.15 to the 4th power and then multiply that times your 250 to get you that 437. Let's go ahead and if you guys have any questions on anything on this first part, please reach out to me because we won't be revisiting interest rates again before the test. So if you want more practice, extra help, please reach out to me. Let's go ahead and move on to the second warm-up problem. So it says Natalie got a job at Starbucks and makes $13.50 an hour. How much money will she have made after 4 hours? So after a 4-hour shift. So there's 2 main ways you could have done this. Some of you guys probably just did, okay, $13.50 an hour times the 4 hours, so I'm gonna times it times 4, multiply these together, and let's see what we get. So I'm gonna do 1350 times 4. Sorry, hold on, my 1350 times 4 is 54. So that would basically be saying after a 4-hour shift, Natalie will make $54. And I know I didn't ask you guys to write this sentence, but it's important to know like what relation do these numbers have with the problem up here? Like what does 54 mean in terms of this problem? 54 is the amount of money she will have after a 4-hour shift. If you didn't do it that way, you might have also just kept adding. You might have done 1350. That would be 1 hour. This would be 2 hours. This would be 3 hours. This would be 4 hours. And you could just add those together. You'll get the same answer of 54. Yeah. So same thing. And then that same sentence would follow. The point of this one is I want you guys to note the difference between Natalie's situation and the interest rate situation we had up here. So notice this interest rate. The pattern we created was multiplying times 1.15 every time. Or if we were adding, we were always adding in a different number. Like we added in 250 here, we added in 287 here, because they were increasing by a percentage. Whereas in Natalie's situation, everything is increasing by the same amount, by that 1350 an hour, not a percentage. So the difference between these two is this with the interest rate. This is considered an exponential equation, exponential. Whereas Natalie's situation is considered a linear situation. Quickly, I'm going to explain what you're going to see on your next slide. Your next slide will look like this. And it's basically just explaining linear situations. So linear equations are an equation in which the leading exponent is 1. And makes a straight line when it is graphed. All that means is, you know how we've been dealing with like x squared, x to the third, x to the fourth, all that stuff? None of these are considered linear equations. Linear is just going to be x to the first power, or just x. So these will be linear. Linear is just an x. Nothing x squared, not x to the third, none of this stuff, just x. Linear equations come in the standard form of y equals mx plus b, which you will see here. Where m is that slope. So I'm going to go ahead and label this as m is the slope. And b is that y-intercept. So b is the y-intercept. Again, you will see this on your next slide, so it'll explain it some more there. The slope is the rate at which things change. So for example, his gas tank gets 30 miles per gallon. That means every gallon, it's 30 miles. So if he's doing 2 gallons, it'd be 60 miles. 3 gallons, it'd be 90 miles. So the slope is basically that pattern. So we can think of it as a pattern, honestly. Pattern. That's what your slope is. Keywords you might hear might be per, like 30 miles per gallon, or an, like an hour type thing, or a minute type. Basically, you're looking for like a constant rate. That's the best way. Constant rate. Those are going to be your slopes. And again, these are only in linear equations. Sorry, I didn't super explain that part. Only linear equations have slopes. Exponential equations do not have slopes. So in linear equations, your y-intercepts, however, they're not the pattern. They're more of the starting point and initial values. So for example, let me actually just write that. So starting or initial value, whichever way you like to call it. And your y-intercepts will be the b in the equation. And how it'll sound, it'll say his gas tank started with 150. So whereas over here, the 30 miles per gallon, that was the pattern. There's no pattern here. It's just what you start with or how much you initially have. That's going to be your y-intercept. on your next slide, you will see this. Feel free to take notes on it. And then you guys are going to have a quiz-is game or a quiz-is where you guys get to sort between slope situations and y-intercept situations. And that's going to help you out with the remainder of the problem.